For stats.
So didn't you say? Oh, so I actually thought the class was from 10 to 12.
No, remember you came in and you saw my timetable and we agreed that it was from 1 until 3. You looked at my timetable and you're like, you are right.
I'm not laughing.
So, but I'm here today. So. I'm here today. My bad. Samantha.
I was like,
I'm one of the first people here. So.
yeah, you are here today. No stress. Okay, so I actually ought to apologize to you guys who were here yesterday. Well, none of you were here yesterday when you did the exercise. Yes. You went there in the second half. Second half. Aha.
What did they do? What did you do today?
We revised. We did this revision exercise 3, but there was a wrong step. Just one wrong step. So yeah, we'll go over it. In fact, I must just erase all of this because I want us to, this is what we're doing today. Today we're literally just doing exercises, okay? But before maybe I go there, maybe let me write these on the board, these two formulas. The formulas for calculating SE. Okay, this is the first one. The other one is this. Okay, or you guys, in fact, you also need to write this somewhere. SE is equals to, I think it's P brackets 1 minus P. We want the square root of this divided by, I think it's N. I'll double check now. Let me double check. And today we are moving because one of my students told me that they tried to do the exercises and the exercises were showing them dust. So.
Wow.
So we need to make sure, because I don't want to see you next year, isn't?
Yeah.
And so these are the formulas for SE. I'm going to do them on the board just now as well, because this is the first step to either or. You guys will see what I mean when I say either or. So here we have SE is equals to standard deviation divided by the square root of N. Then here, we're going to do this in a different color. We're saying SE is equals to the square root of the population 1 minus P divided by N. Okay. And then we might as well write this down as well. How we calculate our Z distribution, our equivalent Z distribution is equals to mean minus U divided by SE. Okay, right, we'll constantly be referring to those. So I think let's start with revision exercise 1. I'm going to actually erase this here. Let me double check that we are recording, because if we miss the recording, oh shame. Those who are not with us, they shall try by faith. Okay, right. Yeah. Okay. Right. So let's start with revision exercise 1. Where are you? There we go. But I want, okay, I have actually inserted it. Okay. So quick recap, ne? when we are looking at the Z, remember, maybe let me say it like this. Remember, we look at the Z distribution in order to find the area under the normal distribution, right? So that area is going to give us the probability that we are looking for. Does it make sense? So we recall that when looking at it, we're saying the area pertains to 0, and your Z is going to be 4 within 0, which is the mean. Remember, the mean is here in the middle, isn't it? 0. And Z to the limit of K. Okay? So everything that falls from the left that's been highlighted, that is the probability. Okay, remember that it's always from basically from here to here is what this represents. Can you see that? Because we're saying it's greater than 0, but it's also less than K. K is the limit. Can you see that? So this is then your area for Z. That's basically what I'm saying. Right. That's fine. Okay. Now, let's get into a question here. So number one, they're saying that, I want to change colors. Can you guys see? Okay. So here they're saying, according to statistics, I didn't check if we're recording. Okay, we are good. According to statistics realized by the Department of Health, 15% of all South Africans have hearing problems. Okay? Then they go on to say, in a random sample of 120 South Africans. So already we know this 15. You can already tell it's important, isn't it? Okay, and this 120 is important. In a random sample of 120, what is the probability of at least 18% have hearing problems? So they're saying within this sample of 120, what is the probability that at least 18%? Can you see the average in terms of the population that they gave us is 15? Can you see? They said according to what? The statistics realized by the Department of Health. So here, this is then your mu. Okay, let's just try redo that again. Say that again. It's the mean, but the mean for the population. Okay, and then this 18, you can call it the mean, but now for the sample. Remember, the sample is a subset of the population, isn't it? So this is 18%, 15%. And then they also told us that the sample, in other words, n, is 120. Okay. Those are the variables that we've managed to establish. Now, before we can calculate or do anything, we need to understand the question. Here they said, what is the probability, right, of at least 18% having hearing problems? So basically, if we're to interpret what they're asking, they're basically saying, what is the probability that X is what? Probability that X is at least. So is it going to be greater than, or less than, or equal to 18? They're saying at least. What are we going to have there? Are you switching on the aircon? It's on, okay. I think, yeah, just a little bit, because it's not bad. Oh, guys, talk to me. Eh? What is the probability that they're looking for? They said at least 18%. So what type of inequality sign or sign are we going to have there? This is going to be an equal. Huh?
Is it not greater than?
It's going to be greater than.
Because 18 is greater than 15.
It's going to be either equal to or greater than. Can you see? Is it making sense? Because we're saying, what is the probability that Aubrey is at least 18 years old? So it means I can only be 18 and older. Is it making sense now? I can't be less than 18. Right. So now we obviously don't know what x is on this curve. Can you see that? We don't know what x is. So we then say, let's get the z equivalent. Okay. So we then say, okay, what is this equals to? We then say, okay, what is then the probability? Here we're going to say z is greater than. But now we don't know what is the equivalent of 18 on the z distribution, isn't it? And that's where now we start over here with our formulas that we have on the board. We don't know this. We need to establish what that equivalent is. So we start. Can you see, we can't apply this formula. Hey, shame, my kids who are online, they can't see. We can't apply this formula. Z is equals to x minus divided by SE. We can't just immediately figure this out because we don't have SE. So your starting point will always be to determine the standard error. That's what SE stands for. We together. Okay. Your textbook or your workbook, they do not do this in this kind of order. This is why you come to class. Okay. If you just look at the answers, I'm telling you now, unless you go maybe to some YouTube videos and then you go to your textbook, then you'll be able to decipher, oh, this is where they are, this is what they're doing. Okay, but the order in which they do it, it's not easy. It's not like step by step, it just flows. Okay, all right. But you'll see, you'll understand this when we go through this together. So here we're then saying, okay, SE is then equals to what? What's the formula? Let me use a different color. SE. Are you stressed, my sister? Are you okay? SE, we're saying, is equals to what? Which one are we going to use there? Sorry, I actually made a mistake here. Eesh. Yeah, we're going to use P. So actually, these are not averages, sorry. These are populations, isn't it? This is the population, right? And this is then the population of the sample. Okay, sorry about that. So we're using the SE, as you are highlighting, the square root here. So it's going to be square root of P, yeah, and then brackets 1 minus P divided by N. So here we're now substituting. Okay, so P we said is 15. So 0.15 square root of that. 1 minus 0.15 is going to give you 0.85. So I'm just going to put 0.85 here. Okay, we together. Divided by 120. Exactly. Yes, 120. That's N. Number of. No, you're right. I'm agreeing with you. Yeah. Okay. Yes. Remember here we said 1 minus P, and P we said is 15. So remember, 15% is the same as 0.15. So when we say 1 minus 0.15, what do we get?
the P's deal with the
population.
and
Yeah,
X and U deal with needs.
exactly. Okay. So even this one is going to change because here the formula that then will be applied is now, but fortunately it's the same in that you say your sample, instead of saying sample mean, you'll be saying sample population minus your population of the entire. Okay. So you see, if you understand these two steps, then you'll be fine. Okay, and you always start here. Standard error first. Once you get your standard error, then we can get our Z distribution equivalent. So here, what do you guys get here for the standard error? Let me move this in the meantime. What are we getting?
0.035.
Are you all getting the same thing? 0.0325. Are we all getting the same thing? Okay. So now we need to apply it to this formula here. We know, I'm going to do this in blue. We're saying 18 minus 15. Okay. And here we should actually be saying 0. Divided by 0.0325. The P with a cap is the population for the sample. So what do we get here? Oh, guys, your time is leaving us. It's leaving us behind. So here you should get 0.92. 0.92. So now going back to this bit here, this, remember this was our whole objective, right? We're then saying and then we're then saying, yeah, let me start here by saying, we said what is the probability that X is greater than or equal to 18? Then we needed to find the probability, the equivalent probability or area for Z is greater than, right? Now we found it, 0.92, okay? That's the number we're looking for on the Z distribution table. But now, before we can go there, remember what I initially started with, this thing here. We are saying that Z falls between 0 and K limit, okay? So we're basically saying that what is the probability of 0 Z? 0.92. That's what we're looking for. You together? Okay. Now, here we were looking for Z that is greater than 92. Now, if you remember learning unit 6, we said again, I did mention this yesterday before you left. So this is 0, right? So then we are saying basically Z is greater than, we are saying that, okay, 0.92 will obviously be to the right of the zero, yes. So let's just call it this, okay? And then this is your 0.92. So this here is basically saying everything to the left and between the 0 and to the left of the 0.92 line. That's the area that we have when we look for the probability on the Z distribution table. So we want, remember they said here, greater than. So we want actually this portion here. Can you see that? So what we then now need to do is, we know that each half of this bell-shaped curve is 0.5. This whole portion here, right, to the left is 0.5. And similarly, to the right is also 0.5. All probabilities equal to, is it making sense now? Okay, so if we want to get this portion here, I'll go back to the blue, right? We then have to say this, now let's look at whatever this probability is minus 0.5 to only get this section here. Let me use a different color. Is that making sense? Because this entire portion here is 0.5, but we don't want the entire portion. We only want this green bit. Does that make sense? So we say 0.5 minus, now let's look up 0.92 on our Z distribution. 0.3212, okay? Which gives us, we're looking for the green part. Because remember what the question asked. What is the probability that X, or what is the probability that, let's go to the actual question. What is the probability that that 120 sample, what is the probability that at least 18% or have hearing problems? So if we're saying at least 18%, that means that 18% and more. So this is why I also put these images here, over here, to say when we say more, can you see? We're looking at the portion to the right of whatever we find ourselves at. Can you see that? When we say we're looking for less than, we're looking for the left side. Can you see that? When we say between, so they'll give you two Z scores. And then you'll need to get the first Z score and the second Z score and minus them. Okay? Because the first Z score will give you the probability between 0 and that Z score, and the probability between the other one will give you the probability between 0 and that Z score. Okay, so then you must get the difference. Okay, we did this in Learning Unit 6 before we started doing the revision. So my advice to you is, and this is why I wanted you guys to do this for homework, because when you see, here I need to apply my mind, otherwise I'm going to get lost. That's when you start to see, okay, I need to really pay attention to what I'm doing and what is my objective. Okay, so anyway, your answer here is going to be 0.183, yeah? 88. Okay. Let me just erase. Okay. Now, here they ask us to interpret. Okay, we're going to interpret nonetheless. So this is the same as saying 17.88%. So here, whenever you want to interpret, go back to your question, right? Here they said, in a random sample of 120 South Africans, okay, what is the probability of at least 18% having hearing problems? So there is a 17.88% chance that at least 18% of this 120 individuals or participants of the sample have a hearing problem. Are you seeing how you connect the dots? Okay, right. So that's the first one. That's the first one. Any questions on this one, guys?
So can you please, like, I'm trying to explain the 0.5 so that I can later on remember the 0.5 from the table. Can you please explain it simpler?
I'll try explaining it a different way.
So,
Okay. Yes.
that green part, the 0.3212, is that the
0 point, which one?
so,
3212.
so is that the
Yes.
SE?
No. Remember, why did we work so hard to get this Z-score? This 0.92. Why?
So we can go to the Z table.
So we can go to the Z table. When we then go to the Z table, that's going to give us a probability. That 0.3212 is the probability. It's the probability, though, of the part shaded in blue. You see what I mean? But we want the part shaded in green. This is now speaking to your question. Okay? Now, for a second, before we get to answering you, we know that under this curve, all the probabilities are equals to 1. Okay? But again, we know that when we are looking at Z scores, that 0 is less than Z is less than K. Our Z score is between 0 and K. We know 0 is the halfway point. So if it's the halfway point, and we know that this whole curve is equals to 1, that means that to the left of 0 is 0.5. To the right of 0 is 0.5. So if all we want is this green section, that means we need to say whatever this probability is in blue minus 0.5 will give us the probability of the green section. Is it making sense now? Okay. Right. Okay. So let's move on to another one. Okay, I think I would advise you need to go over this, but before you go over this, make sure you go to the slides, Learning Unit 6. You start by going through, you just go straight to continuous probability distribution, and then go through those examples. Read through that and go through those examples. This will make sense when you come back to this, okay? Because you need those foundational principles to tackle this, okay? Right, so let's do one more here. Yay! We've used the whole session just for this. Okay. Let's do one more here. Which one should we do? Okay, let's do the second one. And then we'll go to, these are all population questions, okay? So when we go to revision exercise 3, you'll see that those ones are mixed, population and mean. So here, suppose that 25% of all South Africans in a given income and lifestyle category are interested in buying a Porsche. All right, so here, can you see already we've got our P, which is 25%. Okay, then a random sample of 100 South Africans, we've got our N now, which is 100 South Africans. In this category is selected. What is the probability that at least 20% of those in the sample will express an interest in buying a Porsche. So now we've got our P hat. All right, our population for the sample. Again, in order, okay, so let's write out our question. We want to first start, what are we looking for? We're looking for the probability that X, all right, is what? Here they said at least 20%. So we know 20% is involved in whatever we're looking for, isn't it? So you can literally also do this when you guys are doing this question. Did they say is equals to? Did they say is less than? They said at least. So we don't mind if it is either 20% or more, isn't at least? Okay, so it's the same as the last question. So again, we don't know what the value of X is. Okay. And this variable, I see in your book, they use P. Okay, but yeah, you can use X, you can use Z, you can use any variable. It's an unknown. You know, when we do mathematics and we talk unknowns, we can use any, yeah. Okay, anyway, let me not labor the point. So now we start to say, okay, we assume this data is naturally distributed. Okay, this is why we always make the assumption that all data is naturally distributed, so that we can use the bell-shaped curve to find the probability. Are you now seeing the connection? So we are then saying, let's then find the equivalent Z score in order to solve this problem. So then we say, okay, we're basically saying, what is the probability that Z is greater than, but we don't know the Z score. Can you see that? So we say, okay, sharp. We leave it at that for now, whilst we use our formulas to get to establishing what is the equivalent Z score. Okay, now I'm erasing this stuff down here so that we can have some space to do the things that need to be done. Okay, right. Right. So now we say to ourselves again, okay, to get the Z score, again, we look at our formula, we see Z. To get Z, I should have left that. Z is equals to P small hat minus P divided by SE. Again, we don't have SE, so we need to solve for SE first. And that we said is, it's actually here. Let me not rewrite it in the interest of time. Okay, but it's this one here. And you'll see when we are not looking at population, when we are looking at mean, the calculation of SE is slightly different. Okay, so your step one is to get SE before you can get Z. So we said the square root of P we established is 25, so 0.25. Yes. Oh, so it's 20%. But remember, this is the formula we're applying right now. Here I was just saying, I was trying to show you that we can't get Z straight away because we don't have SE. Is it making sense? So I can even just take this and remove it and put it to the side, because right now it's we're not able to even use that right now.
We're only using that formula after we get this.
That's it. You see? Okay. So let me bring this closer, isn't it? Okay. So this is what I was saying about in your workbooks, they don't show you chronologically how you go about this. So then brackets 1 minus population of 0.25. Okay, divided by n, which we know is, in this case, 100. Okay, so If we then simplify, this will then be 8. Let me not even write it out. You guys can solve this. But this in brackets is 1 minus 0.25, which is obviously going to give you 0.75. Okay, so you can say 0.25 times 0.75, then divided by 100. After you solve for that, then you say, what is the square root of what you have obtained? Okay, just one. You are saying that that is equals to 0.0433. Okay, now we have our SE. Okay, now we can solve for, let me bring this back. Now we can solve for Z. Stats. Why didn't I teach this sooner? Are we not having fun, guys? Ow. You guys could have fooled me. So here we go. We are saying now we have our population of the sample, right, which is 20. We have our population, so 0.20 minus 0.25 divided by our SC, which we just calculated, 0.0433. What do we get? What do we get? My sister, I don't see you writing. Yes. You are writing. Okay. No, that's fine. Negative 1,154. That's what they've done also in your workbook, okay? So I'm just going to leave it at that, so we're consistent. So now that we have the Z score, now this is where you guys need to pay attention, because you guys, remember I told you yesterday that when it comes to Z distribution tables, you have a positive and a negative Z distribution table. But you guys don't. In your exam, you're only going to be working with the positive Z distribution table, which is what you have in Appendix 1, the first table. That's the only one you have. You don't have the negative one. So, but that's not a problem at all, okay? But, so basically what we would have been looking, isn't this is 0, ne? This is 0. So this time we're not looking at this side of the, because we're looking at negatives, isn't it? The negatives are going to be where? This side, isn't? Can you see that? So, but the good part, ne, is that, can you see that the bell-shaped curve is symmetric, meaning you can fold it in half. Both sides are equal. Does that make sense? So instead of looking for negative 1.15, we can just look for positive 1.15. And the area between 0 and 1 should be the same. Can you see that? Okay. So then what we now need to do is we then say, okay, therefore we can actually say P, the probability is then 0 Z 1.15, a positive 1.15. Is it making sense? Okay, now, so look up this probability score for me, 1.15, and tell me what that is. 0.4394. Guys, and I need everyone to get this off the, because you need to be able to read the Z-score table. Are you okay?
I'm looking at it, so I don't see 1.15.
Oh, 1.5. Oh,
So you need to go further down on the column. So let's look at it together.
So 0.1 and then.
So can you see here?
So that's 0.
It starts with 0 point and then you come down. Here's your 1, 1. Because you're looking for 115. So then you look for 5.
Oh, okay. Yeah.
Okay. Now tell me if you're getting the same thing.
Is it 0.0596?
0.3749.
Hiban. What's going on here?
So this is
1.1. Okay, so first things first. On the first column, we're looking for 1.1.
oh, it's 0.3749.
And then we look for 0.05, isn't it? Okay, so we scroll down to 0.05 and you're getting 0.. Okay, we're together now. We're having fun, guys. We're having fun.
In the test, obviously, like, there's a table. It's given, right?
Yeah, it's given. But this is why I'm using even this one, because I know this is what you guys are going to get.
Can I see?
It's the same. Yeah,
It's the same as
it's the
the
same. Okay, so we said 0.3749. Okay. Now, remember, when we were looking at, I'm going to copy this here. I want this. Copy. The objective here. The objective here was to get the probability of X being equal to or greater than 20%. And remember, we said when something is equal to, let me do this in red now. I like the fact that we're discussing this because this is where we're going. Now, whenever we get a z-score, if we're saying we want greater than or more than, because that's the same thing, more than, greater than, at least, that's the same thing, okay? We are basically saying this is most the area that we get from the z-score, isn't it? But what we want is this part, because we want more than or at least, isn't it? No, we were minusing 0.5 to get this green part, isn't it? But now because we, over here, remember, we had a negative z-score. And then we said, no, we're just going to use the positive version because they're simultaneous. So we can't minus. We have to do the opposite. We then have to add. So 0.5 plus this 0.3749, which will then give you
0.8749.
So the difference between this one and the first question you did,
yes,
is that we had to minus the 0.5 from the z-score.
Yes.
And then where does it show that in the question where, like, this one we had to minus and now this one we had to add it to the.
Why don't you ask me why? Because both, remember, both we were looking for more than or at least, both. So both were looking for this segment, isn't it? But what was the difference? With the second question that we did, the z-score was negative. Can you see that? No, this is the z-score. The z-score. Can you see? Here we were solving for the z-score.
Also, sir, when it's positive, you minus it.
Yes, when it's positive, you minus it, because that's typically what you're going to do. Because when you're reading your z-score, it's going to be on the right side. Can you see that? But we read off of the left side. So we can't do what we would do if we were reading off the right side. Is it making sense? Okay, so what's very important is I'm going to actually, let me do this. When looking for this, we minus 0.5 unless our z-score was negative. Then we have to add. We have to do the opposite. Now, if we were looking for, I want to draw this for you guys, and I'm going to give you a break just now. I just want to wrap this whilst our minds are on this. If we were looking for less than, right, which means that we would be looking for the area, I'm going to shade it in blue, the area this side. Can you see that? This side. Yeah. So when we're looking for less than, but we know that the z-score has also given us this part in red. We want less than this line. Can you see that? Everything from that point going backwards. Can you see that? We already have the red portion, but we don't have this portion. Because remember, our thing is 0, k, which is this thing here. So z is the red portion in between 0 and k. Can you see that? So if we want less than, which pertains to everything to the left of the line, I'm going to show you the photo again. Can you see less than? Can you see that? That's basically what I'm trying to illustrate. So we are then saying we can't just take this red probability. We need to then add what? 0.5, because we know everything to the left of 0 is 0.5. So can you see, we only added 0.5 here because we had used a negative. But we know that when looking for more than, we should actually be subtracting 0.5. So you need to remember, whenever your z-score is negative, you will do the opposite of what you typically would have done. Okay? Okay, guys, don't worry. Just let's take a breather. Yeah, it's going to take time because you need to practice it. And obviously, you know, you need to just regross yourself with the fundamentals. Because I know, guys, when you guys went to go write your test, everything we did on Learning Unit 6 went out the window. You see? So, yeah, don't worry about that. Guys, let's take a break. Let me see you at 10 past. Then we will go to revision exercise 3, and then we'll deal with that one. And then from there, we'll call it a day. Okay.
So sir, the interpretation is basically at least 87%.
Yes.
No.
Then this probability is 87.49%, isn't it? But what was the question? What was the question?
South Africans are posh.
Yes, we were looking at South Africans and what percentage. We were saying, let's go to the question. Thank you for this, because we didn't actually finish. We need to interpret. So we are saying here, the question says, what is the probability that at least 20% of the 100 South Africans want to buy a Porsche, are interested in buying a Porsche? Okay? So at least 20% of the 100 guys, what is the probability that at least 20% of the 100 guys want to buy a Porsche or are interested in buying a Porsche? So we then say there's an 87.49 probability that at least 20% want to buy a Porsche or are interested in buying a Porsche. Is it making sense? Okay. Can you see why I keep saying when you want to interpret, go back to the question? And then all you need to do is then say, this is the probability of this, what is being asked in the question, in your home draft. Okay. Right. So let's take our break, and then let me see you in yeah, guys, can we just meet at 10 past, because time is not on our side, please. Today you're getting your school. That's your school fees worth, huh?
Sir, I do it every day. So.